Hey, g'day, it's Prezzo. Thanks for joining me in the workshop today. This is part 4 of building the Titan 60 model aircraft engine, and I've got a question for you, so let's have a closer look. Well, here's my question. How can I get that sort of finish on a part that I've turned in my lathe in a home workshop? And this is the part that we're talking about. This is the crankshaft of the Titan engine. This has been turned with a fairly sharp tool with coolant, and it's been rubbed over with some emery cloth when we're done. But that finish there is nowhere near as good as this. Now, this is a piece of ground shafting that I purchased, and you have to ask, how do we get this finish in a commercial situation? Well, this would probably be centerless ground, or it would be held in a cylindrical grinding machine to get that quality of finish there. But I want to do this in a home shop, so how do I do it? Well, I believe the most accessible method for doing this in a home workshop is a process called lapping. Now, lapping doesn't require a lot of expensive tools or materials, and it's sort of achievable with a regular lathe and maybe a few other tools like a drill press and hand tools. And the first step in that process is to make a tool called an external lap. Now, I've never made one before, so I'm looking for advice. So I don't know, do you know? No? What about you? No. Over the back, you're always giving me advice. You know how to do it? No? Okay, guess I have to teach myself. So I don't know, let's head over to the bench. So the material I'm using to make the lap is 6011 T6 aluminium, and it's 40 by 40 by roughly 30 millimeters thick. Now you can use any sort of soft metal, brass, copper, aluminium is good. Cast iron is also very good. But I got stacks of this aluminium, so that's what I chose to use. A lot of the initial marking out you can see me doing here is just to work out where the slots will go and also where the relief holes will be at the end of the slots, but none of this is terribly critical. So I'm using a self-centering 4-jaw chuck here, and when you're putting square stock into a self-centering 4-jaw chuck, you need to very carefully rotate that stock as you close the jaws, and then just feel for when the stock stops rotating, and then you can close the jaws completely. If you don't do that, you may actually be gripping on a distance which is larger than the measurement directly across the two sides of the square. And when that happens and you put the cut on, the part can slip and it will be loose in the jaws. So here again, just you can see how that's rotating. Just slowly close the jaws, and just you get a sense of when it wants to stop rotating. And that's it there. Now fully close it. Right, that was drilled to 12 millimeters, and now we're going to bore this out close to 9/16 and finish with the reamer. Okay, it's going to take the last couple of thou with the reamer. Okay, that hole there is the correct diameter for the finished size of the crankshaft. Now at the moment that shaft is oversized. We're going to have to put some slits into this piece of stock now and expand it put it over the crankshaft with the diamond lapping compound and slowly clamp this together as we lap that shaft, and it should finish parallel and the correct size. Just got one more hole to drill. I'm going to rotate this in the vise so I don't drill into my vise, which would be bad. So this is the layout for the pinch screw. And just while I'm doing this, I realise now I made a mistake, overlooked something. I'm sure there's some brainiacs have already worked out what it was. I can fix it, it's not a problem, it's just that it would have been easier to do it while this was still in the lathe. Okay, that's where we're going to drill for an M6 screw. So this is my clearance drill, that's about 6.2, and we're going to drill just past halfway with this one. I'm just setting my depth stop here. Well, that's where we're at. We get the pinch bolt in there now, and then we'll do the saw cuts. I'm sure you probably realise by now that there's nothing in this that's terribly accurate. The only thing really is the diameter of that bore there, and even that can be within 100th of a millimetre and it will still do the job. So yeah, I've never made one before. It's going to be interesting. Alrighty, so let's get the saw cuts done. Okay, I was lucky there that I could turn that saw blade inside the bore, but that's our 4 saw cuts done. Now, these saw cuts will also help to hold the diamond lapping compound and refresh it as we grind away at the shaft. I deburred inside those saw cuts there with the triangular file, and it didn't open up like I hoped it would. So you can see that it's still quite a tight fit, but you can get something like an old steel rule put that in there, and you can sort of just wedge that open enough to allow the crankshaft to slide through quite freely. And when I release that, it pinches down hard again. So what I'll need to do is sort of get something in there and permanently deform that open, and then the pinch screw will collapse it again and make it pinch down onto the crankshaft as we grind away at it. When I lap this crankshaft, I also want to lap the back of this crank disc. Now, the reason for that is that this crank disc rubs up against a bronze bush in the center of the crankcase, and the action of the propeller in the model aircraft engine pulls the crankshaft forward against that bronze bush. And I don't want to lap the whole of that disc, just an area in the center there, around about 5 to 6 millimeters wide will be adequate. And in order to do that, I have to relieve the lap. So I'm going to face off the outer portion of the lap, leaving a raised concentric ring in the center there. Now, very astute viewers would have worked out that I should have done this all when we had this part set up in that self-centering 4-jaw chuck. And I could tell you a lot of rubbish at the moment about concentricity and planar alignment and all that sort of thing, but at the end of the day, I just forgot. So I'm rectifying that now. So I've got a piece of aluminium stock in the 3-jaw chuck. I've turned that down to 9/16 diameter. We'll pinch down on that, and then when I face this and relieve it, it's all going to be accurate and concentric. That's the plan. Okay, so that's the lap ready to go. Now you might wonder why I chamfered the inner part of that bore there. That's going to leave an unlapped area on the junction between the crankshaft and the crank disc, but I'm thinking that I'm going to undercut that later so we don't get any interference or rubbing at that point. I think we're ready to go with this lapping. So what I've done is I put the crank disc in the 4-jaw and I've dialed in the crankshaft, and I've got the tailstock here for support. And I think the idea is you just put the lap over the shaft and then support that with the tailstock. I mean, it depends on your setup. You may not need tailstock support to do this, and don't want that terribly tight. Got the lathe set to run at fairly low speed, and we're just going to spread the lapping compound on the crankshaft. It'll embed in this aluminium lap, and that carries the diamond honing compound and will work away at that steel. Because the aluminium is softer than the steel, that's where the diamond paste will get embedded, and it will tend to wear, but not at the same rate as the steel. So as the lapping progresses, the lap gradually has to be pinched up tighter and tighter, and that does two things. It keeps the diameter of the shaft reducing, but it also takes up the wear in the lap itself. So the lapping compound that I'm using here is a 5 micron. Now I bought a pack of, I think there was about 7 of these, and they go from 5 micron down to about 0.025 micron. And I believe that this one is, they describe it as a fine finish. Now, I'm not after a mirror finish on this, although, I don't know where you stop with this. I think you just want it to be the correct diameter, and you want it to be parallel, and you want it to fit the bush. I suppose mirror finish would be good, but I'm just not sure if we're going to need that. Alright, so I've never done this before, so if I'm doing it wrong, tell me. You will anyway, I know that. So we're just going to put some of this on the shaft. Now I've got the bed of the lathe covered in cloth. I don't want any of this lapping compound to get anywhere in the working parts of the lathe. So I'm going to put a bit on the face of the crank disc as well. Okay, now at this point the that M6 screw there is loose. So we'll just give this a bit of a grind, see what happens. Well, there's no sensation of anything happening there at all. It sort of feels tighter up toward this end, but I knew that. It was just very, very slightly tapered. And, okay, from where I'm standing I can see the high spots. So there's some slightly polished areas in sort of concentric rings around that surface there. So it's clearly removing some material, but I think it's going to be a fairly slow process. So I'm actually glad I started off with the 5 micron. I think those other ones would just take forever. So I'm going to put a bit more on and then we'll just work away at it. I won't make you sit through it all. We might come back when I've got some progress and we're getting close to it fitting the bush. See that it's quite loose on there. I'm just going to pinch this screw up a bit more. Not sure if you can make that out. That actually feels really polished, but the surface texture is uneven. So it's sort of now getting that sort of almost like a semi-gloss shine on it. And I can see some wear marks where I've been working the lap up and down. It's sort of like that crisscross pattern you get when you're doing sort of a honing on the inside of a cylinder bore. And I guess at some point we're going to have to stop and clean that really well and actually try the bushing on there. But I think it's still tapered. It gets tighter up toward this end. So I'm just going to keep working at it for a bit and then we'll clean it and try the bush. Been at that now for about half an hour and all of the turning marks are gone now, and all I'm seeing from where I'm standing anyway is just a semi-polished finish, and the bush now is going on about a third of the way. I don't want to push that any further in case I get it to gall up and stay on there. And I can feel the lap getting tighter as I get toward this end. Now there's a bright ring around the crank disc, which is good, and the lap seems to be cutting much more effectively now. I think all of that diamond honing compound is embedded in the aluminium. I'm adding a few drops of oil every now and then and refreshing the honing compound, and it seems to be progressing really well. So yeah, we might actually get there. That's how I've been cleaning that. It's just paper towel and white spirit. You just got to keep at it until there's no more black material coming off in the paper towel. Usually takes about 2 or 3 applications. Now I reckon we're pretty close here. I've actually run the mic on this and I'm exactly right all the way along until I get to within about like a millimetre of that shoulder there. But let's try the bush. And yeah, I can feel it getting tight just there, like a millimetre off that face there. Now I understand that's the problem with trying to lap a shaft where you can't run the lap off both ends. So with this one here, this end here, I can run the lap off by about 1/3 of its length, but I can't do that up there. And also there's a radius between the shaft and that crank disc there, which is sort of interfering with how far the lap can go along. Now I did countersink the surface of the lap quite a bit, but it's still not running right up against that shoulder there. So what I'm tempted to do here is just leave that. I reckon that'll just wear itself in eventually. In fact, what I'll do now is just put some oil on this and just keep rotating the shaft in the bush. And that has pretty much done it. You can sort of feel it just going up tight there, but I reckon that'll sort of wear itself in, no trouble at all. But other than that, that fit is absolutely beautiful. It's like a sock on a duck's nose. So there you go, homemade lap, seemed to do the job. Another new experience for me, certainly not as scary as I thought it would be. So anyway, look, let's go over the bench and wrap up. Okay, this is where we're at now. The instructions say to make all of the parts and then do all of the assembly. But for various reasons, I wanted to have the bronze bush inserted into the crankcase before we go any further. Now, one of those being that the crankcase is currently too long, by about 30 thou. And in order to find out where that surface needs to finish, I wanted to have the bush in there and I wanted to have the crankshaft finished. And what I can do now is put this on a mandrel and machine off the excess material at the front here. And also, I just wanted to see the shaft go in there and just see how it rotates. Now, in order to get the bush in there, I put the whole crankcase in the oven. I heated that up to 250 degrees centigrade. I had the bush on a mandrel, steel mandrel, clamped in the vise, and well, what do you know, the crankcase just basically fell on there. Now, the interference fit that I got was about 100th of a millimetre difference. So the bush was about 100th oversized. That's about, what's that, about 3/10 of thou. So it's a nice snug fit now. I don't think it's coming out. So that part of it went quite well. So I guess you're wondering how it all fits. So here's our crankshaft. I put a bit of very light oil on that, and that just drops in like that. Now, it doesn't go all the way, but if I press that down gently, it butts up against the inside of the bush. Now, remember I said that there was a slight tight spot down at the junction between the shaft and the crank disc. Now, I don't know what to do about that yet. I suspect that it's just going to wear in. So I'm not too worried about that at this stage. So if we put the prop on there now, you can sort of see how nicely that rotates at that point there. But of course, it's not fully pushed up against the bush. If I do that, a little bit tighter. So, you know, it sort of doesn't want to spin freely, but like I say, I think that's going to resolve itself eventually. Just before I finish up today, a lot of people have been asking about the availability of these castings for this engine. Now, I've been in touch with George Ginevro's son, and he's trying to track down the patterns for these two parts. And really, these are the only two castings that I guess you really need. But even this part you could probably make from flat stock. The crankcase though is a different matter. If you were to make this from solid billet, that would probably be a CNC type exercise. Now, if I find out that there are more castings available, I'll let you know. But for now, I believe that there are some out there, but they're privately owned. They're sort of kits that have been purchased and never machined. But stay tuned, I'll let you know if that sort of comes about. Now, just before I sign off today, I'll need to tell you that my wife and I are hoping to go on a holiday for 3 weeks, if we can get to Tasmania, and we get a border pass so we can fly into Tasmania. That's what we're going to do. So if you don't see another episode coming out in the next 3 weeks, that's what's happened. However, I do have another video in the can that I'm going to release, but it's nothing to do with this project. So keep an eye out for that one. It's very interesting, and it should be out in about a week and a half or so. So that's it for today, guys. Thanks for sticking with me on this build, and thank you to all the new subscribers, and there are lots of them, and that's wonderful to see. Certainly this project has sort of sparked a lot of interest, which is wonderful, really. So for now, it's Preso signing out. I'll see you next time. Don't know when that is, but stay tuned. Okay, cheers. Ow, hot. And the first step in this process is making an external. The method it's. Now, lapping doesn't require a lot of expensive tools. And the first step in this process is making an external lap. God, that's hard to say. Is making an external lap. And the first step in the process is to make an external lap. And I guess I have to find, and that would probably be a CNC type exercise. Fuck's sake.